Looking at scatter plots, sometimes we are given an x value and we want to be able to predict what the y value or the outcome will be. It is very important that we avoid making predictions that run outside the range of the current data set. This is called extrapolation and is not very reliable. To be able to predict values of y, we're going to first create what's called a residual plot to determine if there really is in fact a linear correlation. Because while we can plot some data points and see it kind of sort of looks like it's a positive or negative linear correlation, there is a way of being able to determine if there truly is a linear relationship, and that's with a residual plot. Then, if a linear correlation really does exist, we can then substitute the given x value into what we call a regression equation or a least squares regression line. If there is no linear correlation, then regardless of whatever that y value is, or x value, we'll be able to predict what the y value is based off of the mean or the average of the values. So in that strategy, there was a lot of different terms thrown around. Some of them were things like residual plot, regression equation. So we're going to go through some of those key terms and look at those definitions. The first is a residual plot. A residual plot is just another type of scatter plot that it uses the current data and it is used to determine if there is a linear relationship. With a residual plot, when you graph, you are looking for no noticeable pattern. This implies that there is a linear relationship to the data that you are plotting. Coordinates of a residual plot are of the form x, and then the y coordinate is y minus the predicted value of a y, known as y hat. The residual is given by y minus y hat, or this value here as the plotted y value. Those are indicated by looking at the difference between the observed value and the predicted value. Once we've determined that a linear correlation exists, we can then use our graphing calculator to find the least squares regression line. Now, if you recall from algebra, normally straight lines are in the form y equals mx plus b. In your graphing calculator, you're going to be looking at using a feature called lin-reg or line regression, and it looks like it's in the form of y equals a plus bx. So I want to show you exactly what those variables represent. A least squares regression line is in the form of y hat, which again represents our predicted value. B sub 0 represents the y-intercept, and B sub 1 represents the slope of this line. So in this equation, we can look at any input value and predict the outcome or the y value. But again, this line should never be used to predict values outside the current data value, the current data set. It's also important to note that the B sub 0 and the B sub 1 values are values from a sample. So you're going to be looking at sample data, and those values come from that. The correlation coefficients, this is used in terms of a lowercase r, and you're going to see this on your calculator. This value is also calculated from the sample data. It also gives us the strength and direction of the linear correlation, where the value of the correlation coefficient is between -1 and +1. We can have decimal values. We could be exactly -1, exactly +1. But if we are exactly -1, or as we get super close to -1, that means we have a strong negative linear correlation. And if we are exactly 1 or getting super close to a +1, that means we have a strong positive linear correlation. And as we get closer and closer to 0, that means that we have no correlation. We also have what's called a coefficient of determination. This is represented by r squared. This measures how well the least squares regression line that we are creating fits the actual data. When calculating r squared, the closer we get to +1, the closer we can be confident that the predictions are to the actual values on average. Because we are calculating a least squares regression line, the values are not going to be exactly perfect, so we need to have some rounding rules. We're going to round all of our values for A and B in our least squares regression line to 4 decimals. For R and R squared, we'll round to 3 decimals. And for Y hat, or our predicted value, we will round to the same decimal values as whatever the original data set is.